All right, we're going to be looking at Excel 3-2. It's a density Excel spreadsheet, and you're converting values from one density to another. So you have your instruction tab that explains to you step by step what they want you to do, and then you have the questions, which is the actual spreadsheet. And what you'll notice here is that you have different materials: helium, air, liquid hydrogen, sodium, some different values here. And you have the densities of these items given to you in kilograms per meters cubed. And what we're wanting to do is convert from kilograms per meters cubed into pounds per inches cubed. And then we're going to want to scale things using 100 for the gold, and we're going to scale things using 1 for water. So also on this spreadsheet, you'll notice at the top they gave you some conversion factors. They gave you that 2.2 pounds equals 1 kilogram. And they also gave you that 100,000 cubic inches is equal to 16.387 cubic meters. So what we're wanting to do is to use that information and the information in the table to do our conversions. So at this point I want to switch over and I'm going to show you what I've written down. And so what we have here is some conversions for us that we're going to talk about. So in part A, they're asking us to convert the density in column C that is currently given to us as kilograms per meters cubed, and we need to convert that into pounds per inches cubed. We're given that 2.2 pounds equals 1 kilogram, and we're given that 100,000 inches cubed equals 16.387 meters cubed. So we're going to use a concept called dimensional analysis to do the conversion, and then we're going to put it into Excel format. So remember, with dimensional analysis, we're just going to multiply everything together. We are not going to set up proportions and cross multiply. So we're starting off with kilograms per meters cubed, and we want to get into pounds per inches cubed. So we're going to use this information that we're given here, the 2.2 pounds per 1 kilogram and the 100,000 inches cubed, and we're going to think about our conversions. So the first conversion I wrote here is 16.387 meters cubed. I'm taking this information, divided by 100,000 inches cubed. Now notice how I wrote it. I'm multiplying this number by this value. So the meters cubed with dimensional analysis will cancel out. And so once they cancel out, I'll be left with kilograms per inches cubed. So remember, what I'm trying to get is inches cubed on the bottom. Well, I've got inches cubed on the bottom now of my fraction. So now what I need to do is convert the kilograms into pounds. So I'm going to use my other conversion, the 2.2 pounds equals 1 kilogram, and I'm going to write it 2.2 pounds over 1 kilogram. So what happens now is the kilograms cancel out, and I'm left with pounds. So once I do all of this calculation, I'll be ending up with pounds over inches cubed, which is what I want. So this value here comes from my spreadsheet, and I'm just using the cell location C9 for right now. So what's going to happen is I'm going to take C9, I'm going to multiply it by 16.387, I'm going to multiply that by 2.2, and I'm going to take all of that and divide it by 100,000. So I'm going to take the C9 location, I'm going to multiply it by 16.387, I'm going to multiply by 2.2, and then I'm going to divide by the 100,000. So if I do that calculation, I'm going to end up with the solution for my first cell. Now, my only problem is, well, let's go back for a second. We're going to go back to the spreadsheet and look at it. So here's what we're looking at here. So C9 is helium. The 16.387 is here in F5. The 2.2 is in B5. And the 100,000 is in E5. Okay, so if I go back again and look at my formula that I've got here, so notice what I said here is I'm going to take C9 times the 16.87, but that's located in F5, and I'm going to multiply it by the 2.2, which is located in B5, and then I'm going to divide by the 100,000, which is located in E5. So if I go back to my spreadsheet, if I take that information and I type that in here, equals C9 times the 16.387, which is F5, times the 2.2 divided by the 100,000, I get an answer. And the answer is in, notice this E06, that's called scientific notation. So I do want to make sure, because it tells me in my instructions to make sure it's in scientific notation to any number of decimal places. So I've got to make sure that I actually click on that and change it up here to scientific notation. So I'm going to make sure I choose number, and I'm going to choose scientific. Okay, so then I've got it in scientific notation. Now here's my problem. When I fill it down, I get this divide by 0 arrow, because now look at what happened. Oops. Sorry. Okay, so instead of having F5 and B5 and E5 here, I've got F6 and B6 and E6. Well, F6 is this blank cell right here. Notice these highlighted cells right here. So when I fill down, I need to make sure that I've got absolute cell references. So back to our paper. So when we're looking at these, the F5, the B5, and the E5 need to be absolute cell references, and we do that by putting the dollar signs around them. So I'm going to let you go back, and you're going to have to make those changes to your spreadsheet, and then you're going to fill that column down. Okay, does that make sense? So you're going to copy, make those changes to the cell, and then you're going to fill it down. All right, so now let's look at the next part. Okay, so part B says, create a new scale by setting the density of gold equal to 100 and adjust all of the other densities proportionally, and then format it to 3 decimal places. So here's what they're asking you to do for this. Gold is way down here. So gold is right here. Gold is at B58. So the density of gold is 19,320 kilograms per meter cubed. And we want to convert that density so that 100 will show up there. So the way that we're going to do this is we're going to set up proportions. So let's go back to our... So we're going to set up proportions. We want to set gold to 100. So currently gold is located in C58, and the actual value for gold is 19,320. So we want to use proportions this time. So 19,320, we want it to be proportioned to 100. And for example, helium is 0.179 over x. So if I cross multiply now, I end up with 100 times 0.179 equals 1920x. And then if I divide by the 19,320, I end up with x equals 100 times 0.179 divided by 19,320. So the 100's never changing. It's always going to be 100. The 19,320 is going to be a cell reference, C58. So this is our formula that's going to go in E9. It's going to be 100 times whatever's in C9, which is the 0.179, divided by C58. But C58 never changes, so again, I have to do an absolute reference. Okay, so now let's go back and look at our spreadsheet. So what they're telling us to do in our first column, our first cell location for B, we decided that we were going to do equals 100 times C9 divided by, remember we've got to do our cell referencing, C58. And then of course make sure you do your formatting. But I want to drag this down and show you really quick what happens. So remember what we were trying to do is we were trying to scale it so that gold equals 100. And notice right here, gold is now 100. Now I did type that in there, but let's do, you know, if we fill that down, or if I delete that and then fill it down, you're going to see it actually equals 100.00. Oh, it's not going to do it. So, but if we look at our formula that we have over here, we'll notice that we have the correct formula, and we can make it have the correct number of decimal places. All right. So our next thing is they asked us in the next part, let me go back again. In the next part, they said, create a new scale by setting the density of water to 1 and adjust all the other densities. Okay, so then we're going to do the same idea, but for part C, we want to use water, and water is in location C23, and it's 1,000, but we're going to set it to 1. And again, I'm going to do the C9, which is the 0.179 over x. And if I do my cross multiplication, I end up with 0.179 times 1 divided by 1,000. And 0.179 is located in cell C9. And C23 is the 1,000. And again, I'm going to use absolute referencing for this when I type it in. So this formula is going to go into cell F9. Okay, so that's what we're typing in F9. And then you're going to fill it down again. Make sure you've done your formatting. It tells you 5 decimal places, 4 decimal places. Over here, it tells you to make sure that it's a number with 3 decimal places and a number with 5 decimal places. The last couple parts are, they're asking you to do a clustered column chart for B8 through C62. So we want to select from B8, which is the material, all the way down to the bottom of the density, and you're going to do a clustered column chart. And in that clustered column chart, you're going to make sure that the title is correct. Okay. One other thing is they want you to compare, what if I have a chart that has the material column and the gold scale. So notice what I did there is I held down the control key. I highlighted material from material down, and then I hold the control button on my keyboard and I highlight this, and I can highlight 2 different columns that are not adjacent, and I can create a clustered column chart with that information. and compare it to my other clustered column charts. And so that's what you're going to want to do to answer that last part about whether it makes a difference. So I hope this helps, and I hope y'all are having a great week.